Bismillahirrahmanirrahim. My name is M.Yaseen, Edwrdes College, Peshawar, Pakistan. Dear students, good morning. Today we will start exercise 4.5, which is related to chapter number 4, sequence and series, first year mathematics. Question number 1. Compute sum. Question number 1, part number 1. Given that 3 plus 6 plus 12 plus up to so on, and the last term is 3 into 2 raised to power 9. Solution. In this case, the first term is 3. It is a geometric series because the common ratio is in this case is 2, because 6 divided by 3 2, 12 divided by 6 is 2. So, it is a geometric series. In this case, the common ratio second term divided by first term, which is equal to 2, and 2 is greater than 1 because we have two cases. If r is greater than 1, then summation formula is Sn is equal to a1 r raised to power n minus 1 divided by r minus 1. Say this is equation number 1. We already have discussed in theory. How many terms are there? We can easily find the number of terms by the general formula of geometric sequence, which is an, a1 r raised to power n minus 1. In this case, this is the last term, this is basically an. So, n in this case is 3 into 2 raised to power 9, a1 which is first term, which is 3, r in this case is 2, n minus 1, 3 cancel. So, 2 raised to power 9 is equal to 2 raised to power n minus 1. So, we know that if a is equal to a power x, a power y, if and only if x is equal to y. So, in this case 9 is equal to n minus 1. So, in this case number of terms are 10. So, simple putting the values in equation number 1 and we get the sum. So, S n is 10 is equal to a1 is 3 into r is 2, n is 10 minus 1 divided by r is 2 minus 1. So, after simplification, this is equal to 3 into 2 raised to power 10 minus 1. This is the sum. In case of geometric series, if the geometric series in this case is 3 plus 6 plus 12 plus up to 3 into 2 raised to power 9. Next part is eight plus 4, 8 divided by 2, 4 divided by 2 plus up to so on. Okay, in this case geometric series like that. So, and plus 1 by 16. Compute sum. In this case, the first term in this case is a1, which is 8, and the common ratio in this case is 2 half, because 4 divided by 8 it is 1 by 2, and the last term in this case is this one. So, first of all write the formula for the summation. In this case r is less than 1. So, summation formula is Sn a1 1 minus r raised to power n divided by 1 minus r. In case of r is less than 1, summation formula is this one. So, say this is equation number 2. ठीक है. In this case we use one formula. If r is greater than 1, we use formula number 2 if r is less than 1. How many terms are there? We can easily find by the general formula for the geometric sequence. A in this case is 1 by 16. A1 in this case is 8. R in this case is 1 by 2 half. 16 can be written as 2 raised to power 5. 8 multiply on both 8 divide on both sides, so 8. This can be written as 2 raised to power 4, 2 raised to power 3, and this is 1 over 2 n minus 1. This can be written as 1 by 2, basis of same power must be added, so this is 7, and this can be written as 1 by 2 whole powers, and because 1 raised to power 7 is 1, so this is 1 over 2 n minus 1. So in this case 7 is equal to n minus 1. So number of terms are in this case is 8. So simple, put the values in formula number 2. S n in this case is 8. A1 is in this case is 8. 1 minus r in this case 1 by 2 whole raised to power n, and n in this case is 8 divided by 1 minus r. So this is 8, 1 minus 1, 2 raised to power 8, and this is 1 by 2, because 2 ones are 2, 2 minus 1 which is 1 over 2. So this is 2 8s are 16, and this is 2 raised to power 8, and this is 2 raised to power 8 minus 1. This can be written as 2 raised to power 4. This is 2 raised to power 8 minus 1. So this is equal to 1 by 2 raised to power 4, and this is 2 raised to power 8 minus 1. So this is the sum in case of this type of series if r is less than 1. Next question is, some of the components are given and some of them are missing. Question number 2. An, R, N, A1, Sn. Part number 1. The components which are given, A1 is given in this case, R is given in this case, A1 in this case is 1, R is minus 2, and the last term is given which is An, which is 64. In this case missing are n number of terms and summation S n. Two components are missing in this case, which is number of terms and the values of summation Sn. So we know that An is equal to A1 r raised to power n minus 1. An which is last term, which is 64, A1 which is equal to 1, r is minus 2. 64 can be written as 2 raised to power 6 and minus 2 raised to power, because there is a even power, so this minus should be converted into positive sign. So this is minus 2 raised to power n minus 1. The reason behind making negative sign is that because there is minus 2, so this can be written as 6 is equal to n minus 1. So in this case number of terms are 7. Next one, find Sn, and we know that summation Sn is equal to r is less than 1, so summation formula is A1 1 minus r raised to power n divided by 1 minus r. So in this case number of terms are 7. A1 is 1, r in this case is minus 2 raised to power n is 7 divided by 1 minus r, so minus into minus plus. So this is equal to S7 is equal to 1 into 1 minus plus 2 raised to power 7, because minus 2 raised to power 7 minus minus plus, because there is a odd power, so there is a negative sign, so negative negative positive, divided by 3, and this is equal to 1 plus 2 raised to power 7, this is equal to 128 divided by 3, and this is equal to 129 divided by 3, this is equal to 3 4s are 12 and 3 3s are 9. This is the S7 in this case, which is the sum. Next question statement is find the first 5 terms and the sum of an infinite geometric sequence having a2 which is 2, second term is given, and the third term which is 1, second term is in this case is 2, and the third term in this case is 1. Find the first 5 terms. Solution. Definitions of common ratio is an divided by an minus 1. We already have discussed in theory. So put n is equal to 3, n is equal to 3, 3 minus 1, this is 2, a3 is given which is 1, a2 which is given 2. So in this case r value is 1 by 2. How we find first term? We know that an is equal to a1 r raised to power n minus 1, replace n by 2, so this is a2, a1 there is a question mark, r in this case is 1 by 2, n minus 1. So a2 is in this case is 2, and a1 in this case is, we have to find a1, 1 over 2 n minus 1. So we use the definitions we simply using the definitions of geometric progression. So 2 a1 n in this case is 2, so this is 1 by 2 raised to power 1. So after cross multiplication, this is equal to a1, this is case 2 2s are 4. So now we have to find the sequence. So we know that the geometric progressions are a1 r square up to so on. First term in this case is 4, first term is 4, r in this case is half, which is 1 by 2, a1 first term is 4, r in this case is 1 by 2 square plus up to so on. So this is 4, this is 2, and this is 1, and 4 divided by 2, this is 2 divided by 2 which is 1, and next term must be, this is 1 by 2 and 1 by 4. These are the first 5 term in this case if the geometric series is given. There is another part in this question. Find the sum and sum formula in case of infinite geometric series S infinity, which is a1 divided by 1 minus r. We already have discussed in theory, a1 which is 4, r which is 1 by 2. So this is 4, 2 1s are 2, 2 minus 1, this is 1 by 2, and here this is equal to 8. So in this case the sum of infinite geometric series is 8. Dear student, next question is question number 4. Find the value of, this is a question mark, find the value, first part 0.8 bar. It means that this is 0.888 up to so on. So in this case find the value. So very simple, 0.8888 up to so on. This can be written as 0.8 plus 0.0. Instead of this 8, write 0, and the next one is 8. We can be write in this form. So in this case 0 point, how many zeros? There must be 2 0, and the next one is 8 plus up to so on, in this way up to infinity. Once again 0.8 plus 0 point, instead of this 8 there is a 0, and the next 8 plus 0 point, how many digits are there? 2 0. So 2 0, and the next one is 8. In the next step 0.00, and the next 8 up to so on. It is clearly an infinite geometric series, because why? It is infinite geometric series, because in this case is A1 is 0.8, and the common ratio in this case, next term divided by previous term. After simplification, this is 1 by 10, because this is 1 by 100 and this is 10 by 8. So there is 1 by 10, 8 cancel. In this case r is less than 1. So if we divide third term by second, then again the same result, which is 1 by 10. So it is infinite geometric series. How we can find sum? So sum formula is S infinity A1 divided by 1 minus r A1, which is first term, 0.8, and the common ratio in this case is 1 by 10, which means 1 by 10. 1 by 10 can be written as 0.1, because 0.1 means this is equal to 1 by 10. So 1 minus 0.1, this is 0.8 divided by 0.9, point cancel. So this is 8 over 9. It is the value of 0.8 bar. Bar mean it is repeated infinite time. So S infinity is 8 over 9. If we divide 8 by 9, the answer is 0.88 to so on. So this is the value and answer of this question. Dear student, the next part is 1.63 bar. This can be written as 1 plus 0.63 bar, because it is 1, there is no repetition, but 63 bar, it means it is infinite times repeated itself. So say this is equation number 1. Our target is to find the values of this number 0.63 bar. So 0.63 bar, this can be written as 0.636363 up to infinity. This can be written as 0.63 plus, how many digits are there? 2 digits. So 2 0 0 0 and 63. So there is how many digits are there? 4. So 0.1 2 3 4 and 6.3 plus up to infinity. We can write in summations form up to infinite time. It is infinite geometric series. So in this case A1 is 0.63 and the common ratio is second term divided by first term 0.63. So points, there is a point, so write 1, and how many digits are there? 4. There is a point, write 1, and how many digits are there? 2. So 2 0 cancel with 2 0 and 6 3 cancel with 6 3. There is 1 over 100. which is r and which is less than 1. So s infinity sum in this case we can easily find by using this formula, a1 which is 0.63 divided by 1 minus r in this case is 1 over 100 and this is 0.63, 100 ones are 100 minus 1, this is 99 over 100 and this can be written as 0.63 multiplied by 100 and to 1 over 99. There is a point, so 1 and 2 digits 0, so 0 0 cancel. So there is simply 63 divided by 99. This also can be written after simplification. 3 2s are 6, 3 1s are 3 and this is 3 3s are 9 and 3 3s are 9. Equation 1 implies that this is the value of 0.63 bar. So 1 plus 21 over 33, 33 ones are 33 and plus 21. So this is equal to 54 over 33 and this is the value or answer in this case. Next question number 5, find or such that. Question number 5, find the values of r given, condition is given, the sum of 10 terms is equal to, the sum of 10 terms is equal to 244 times of 244 times of S5. Solution simple, use formula Sn is equal to a1 1 minus r raised to power n divided by 1 minus r. Simple, replace n by 10. So and replace n by 5. So equation 1 implies that S10 mean a1 1 minus r n in this case is 10 divided by 1 minus r is equal to 244 a1 1 minus r and n in this case is 5 divided by 1 minus r. So this is cancel with this and a1. So there is 1 minus r raised to power 10 and 244 multiply with 1 244, this is 244 r raised to power 5. So left hand values convert to the right, so this is r10 minus 244 r5, this is plus 1, so there is must be change of sign minus 1, so 244 and this is becomes after addition this is 243. So simple factorize and get the values of r. So this is r10 minus 243 r raised to power 5 minus 1 r raised to power 5 because minus 1 minus 240, this is minus 244. This is plus 243 because there is a positive 244 and there is minus 1. So this is plus 243 is equal to 0. So simply we add these values, we get minus 244 and if we multiply we get positive 243 r raised to power 10 and this is 243 r raised to power 10. So there is common is r power 5, so there is r power 5 minus 243, there is minus 1 common, so this is r power 5 minus 243 is equal to 0. In this case r raised to power 5 minus 243 common and there is r raised to power minus 5. So the product of 2 factor 0, this implies that r raised to power minus 5 243 is equal to 0 or r raised to power 5 minus 1 is equal to, this can be written as 3 raised to power 5. Negative to the right, this is must be converted into positive sign and 243 can be written as 3 raised to power 5 and this can be written as 1 raised to power 5. So in this case r values is 3. and it is not acceptable because it is 1, and if we put r1 there is 0, so divided by 0 it is undefined infinity, so it is not acceptable, reject this one. So in this case the r value is 3. Question number 6 statement, show that Sn into S3n minus S2n is equal to Sn minus S2n whole square. Prove that. Prove and take the left hand side. There are lot of method to prove that, so simple is that, take left hand side, prove left hand side, and this is left hand side. Sn formula A1 1 minus r raised to power n divided by 1 minus r S3n, it means that A1 1 minus r raised to power n, in case of n there is 3n, divided by 1 minus r. Simply we using the formula of summation in case of geometric series. There is option whether r is less than 1 or greater than 1, we can use both formula. So we are using in this case if r is less than 1 minus S2n, again formula A1 1 minus r raised to power there is 2n divided by 1 minus r. In this case A1 is common and 1 minus r is common. So A1 common, so there is A1 square, and 1 minus r common, so there is 1 minus r square. This can be written as A1 square divided by 1 minus r whole square, and there is 1 minus r raised to power n into 1 minus r raised to power 3n minus 1 minus this is plus r raised to power 2n. After simplification, minus positive signs are cancelled, so there is A1 square 1 minus r power n divided by 1 minus r, and there is r raised to power 2n common in this case, so r power, so there must be 1, and there is r raised to power n, and r raised to power 2n in this case is common. Once again be careful, r raised to power 2n common, so there is positive 1, there is r raised to power 2n common, there is minus r raised to power n. In this case bases are same, power must be added, so this is A1 1 minus r power n whole square divided by 1 minus r whole square, and there is r raised to power 2n. We are trying to produce square in a whole because there is a square Sn minus S2n whole square. So there is A1 square 1 minus Rn whole square, this is 1 minus r square, and this can also be written as r power n whole square, because by exponent law this is once again is r raised to power 2n. So in this situation we created square in a whole, so this can be written as A1 1 minus Rn divided by 1 minus r and whole raised to power 2. Now we produce in this bracket Sn and minus S2n. Square is there which we needed. So A1 Rn multiply with 1, this is Rn minus, bases are same, power must be added, this is R2n divided by 1 minus r whole square. Now dear student, we know that Sn, this is equal to a1 1 minus r raised to power n divided by 1 minus r, and S2n, this is equal to a1 1 minus r raised to power 2n divided by 1 minus r. It means that we must create 1 minus r raised to power n in this case, because we need Sn, and we create minus r, 1 minus r raised to power 2n. So only the deficiencies in this case is 1 if we add and subtract 1. So this can be written as a1 1 with negative sign with positive sign, so plus r n minus r 2n divided by 1 minus r whole square, because positive negative sign cancel, so there is again become previous step. So this can be written as a1 and one minus r raised to power 2n plus 1 plus r raised to power n divided by 1 minus r whole power 2. This can be written as, because this is minus r power 2n and this is positive 1, this is minus, this is minus 1, and this is plus r raised to power n. So this can be written as a1 divided by 1 minus r and 1 minus r raised to power 2n, and this is minus a1 divided by 1 minus r and 1 minus r power n whole power 2, because minus plus minus and minus minus plus, and a1 divided by 1 minus r multiply this one, and this value is multiplied this one. So this is a1 1 minus r power 2n divided by 1 minus r, and this is a1 1 minus r power n divided by 1 minus r whole power 2, and this values is equal to s power 2n, and this is the formula of Sn whole square, but we needed Sn minus S2n whole square. So there is no danger if a minus b whole square, this must be equal to b minus a whole square. For example, there is 2 minus 3 whole square or 3 minus 2 whole square, because this is minus 1 whole square which is positive 1, and this is equal to 1 whole square, this is equal to 1. Both in both cases they are same, so we can easily shuffle, because there is a positive, there is a square even numbers, so positive sign must. So this is S n and this is S2n, which is equal to right hand side, hence proved in this case. Very very simple, I already explained in detail. Next question number 7, find the sum of n term if the general term is given. Very very simple question. Find sum if the general term in this case is given, which is an 1 by 2 whole raised to power n. So replace n by 1, because sequence is a function whose domain is a set of natural number or subset of natural number, so put n is equal to 1. So this is a1, this is 1 over 2, and the second term n replaced by 2, this is 1 over 4, because 2 raised to power 4, and the next term replace 3, So this is 1/8 up to so on. So find summation. So sum all these terms, this is 1/2, 1/4, 1/8 plus up to so on. So find out sum. So simple in this case, or values in this case is less than 1, because if we divide 1/4 with 1/2, common ratio is equal to 1/4 multiplied by 2/1. This is 1/2, which is less than 1. So summation formula in this case, Sn a1 1 minus r is to power n divided by 1 minus r. So in this case a1, which is 1/2, r in this case is 1/2 whole power n divided by 1 minus r, which is 1/2. So simplified that, 2 ones are 2, this is 1/2 and this is 1/2 cancel simply. So there is LCM, which is 2n. So this is 2n minus 1. This is the some very simple, not difficult. Next question, question number 8. Sum of three numbers in geometric progression is 38 and their product is 1728. Find the numbers. Let's start. Let the numbers are, let the required numbers are A over R, A and AR form geometric progression, because if we divide the second term with the first term, this gives us R. If we divide the third term with the second term, this gives us R. So it is a geometric progressions. So the first the first condition that the sum of these three numbers is 38 and the product is sum mean. So A by R plus A plus AR. In this case the sum is 38. A is common in this case, so there is 1 over R plus 1 plus R, this is equal to 38. So in this case A, take R LCM in this case, so this is 1 plus R and plus R square, this is equal to 38. Second conditions of the question is that the product in this case is 1728. So it means that A over R multiply with A and multiplied with AR, this is equal to 1728. So in this case R is cancelled, so there is A cube, so this is 1728. So A raised to power 3, this is 1728. Taking the A cube on both sides, in this case A values is 12. Say this is equation number 1. So simply replace A by 12 and we can easily find the values of R. So 1 implies that A values is 12, this is 1 plus R plus r square is equal to r multiplied with this 38, so this is 38 r. So 12 ones are 12 plus 12 r plus 12 r square, and this is 38 r is equal to 0. Shift to the left side, so this is 12 r square and this is equal to minus 26 r, and this is plus 12 is equal to 0. So simplify and get the values of r in this case. So dear students, after simplification, factorization, we get the values of r, which is 3 by 2 and 2 by 3. There are two cases, but the answer are same. If we use 3 by 2, answer is 8, 12, 18. If we use 2 by 3, answer is 18, 12 and 8. So both options are available. So first number is a over r, put a is equal to 12 or r is 3 by 2. So this is 3 4s are 12, so there is 4 into 2 8, and the next number is a, which is 12, and the next number is a is 12 and r is 3 by 2, so this is 12 with the cancellation with 2 with 6 and 6 3s are. So the required numbers are in this case is 8, 12 and 18. In this case, if we sum these number, this must be 38, 12 plus 8 20, 20 plus 18, this is 38, and if we product multiply them, the product must be this is equal to 1728. It is all about the question number 8. Dear student, the next question statement is that the sum of the first 6 term, it means that S6 of a geometric series is mean equal 9 times mean multiply the sum of its first 3 terms, it means that S3. Find the common ratio in this case. So very simple. S6 using the formula of sum of geometric series A1 1 minus r raised to power n, and in this case is 6 divided by 1 minus r is equal to 9 times S3, which is A1 1 minus r raised to power 3 divided by 1 minus r. So 1 minus r cancel, A1 is cancel, so there is 1 minus r raised to power 6, and this is 9 ones are 9 minus 9 r raised to power 6. So this is equal to minus r 6 to the right positive minus r raised to power 3, and positive this to the right negative, so this is my plus 8 is equal to 0. So simply factorize and get the values of r, which is very simple. So dear student, after simple factorization, we get the values of r's, which is 1 and 2. So reject 1 because at n r is equal to 1, the sum is not exist possible. So in this case the r values is 2. Next question statement, how many terms of the series, it means that find the number of terms. If the series is given and the sum is given, it means that this is finite case. The geometric series is given 1 plus under root 3 plus 3 up to so on, it is geometric series. Summation is given. How many terms are required? If the sum is this one, in this case we have to find the values of n. So very simple. Summation formula, we know that Sn A1 r raised to power 1 minus r raised to power n minus 1 divided by r minus 1, because in this case A1 is 1 and the common ratio in this case is under root 3 divided by 1, and which is greater than 1. That's why we are using the formula. If this one, if r is, because in this case r is greater than 1, simple putting the values in this formula, Sn, which is equal to 40 plus 13 times of under root 3 is equal to A1 in this case is 1, r is in this case under root 3 whole raised to power n minus 1 divided by r is in this case under root 3 minus 1. So simplify and get the values of n. So dear students, simply multiply and simplify that, take cross multiplication. under root 3 minus 1 with multiplied with this value. Be careful, under root 3 into under root 3, this is under root 3 whole square, and root with cancel square, this is simple 3, and there is plus minus minus. So after simplification, very simple, 40 under root 3 minus this is 13 time of under root 3, so 40 minus 13, this is 27, and there is minus 40 plus 39, this is minus 1, this is minus 1 cancel with minus 1. 27 can be written as 3 raised to power 3, and this under root 3 can be written as 3 raised to power 1 by 2. This can be written as 3 raised to power 1 by 2 whole power n, and this is n 1s are n by 2, bases are same, power must be added, so 2 3s are 6, 6 plus 1, this is 7 by 2. So exponent law, so if a power x is equal to a power y, this is x is equal to y, if and only if. So 7 by 2 is equal to n by 2, 2 to cancel. So in this case the number of terms in this case are 7. Dear student, the next question is, show that a raised to power q minus r, b raised to power r minus p, c raised to power p minus q, this is equal to 1. If given that the pth term mean ap, and this ap we know that ap is equal to a1 r raised to power n p minus 1, because we know that like nth term mean in case of geometric series a, and this is a1 r raised to power n minus 1. If pth, it means that a raised to ap, this is a1 r raised to power p minus 1, and qth mean a1 r raised to power q minus 1, and a r, this is equal to a1 r raised to power r minus 1. So in this case we simply prove that the product of a, b, c and with the power this one is equal to this one. So in this case pth term is given, which is a, and the qth term given, which is b, and the rth term, which is c. In this case in question mentioned that the pth term is a, qth term is b, and the rth term is c. So simply in this case pth term a, which is equal to a1 r raised to power p minus 1, say this is equation number 1, and the qth term, which is b, and which is equal to a1 r raised to power q minus 1, say this is equation number 2, and the rth term, which is c, a1 r raised to power r minus 1, say this is equation number 3. So simply multiply a, b, c, what we needed, power a raised to power q minus r, b raised to power r minus p, and c raised to power p minus q. So taking power on both sides, q minus r in equation 1, and in equation 2 r minus p, and in equation 3 p minus q, and multiply left hand sides all values of equation 1, 2, 3, and the right hand side values of all equations 1, 2 and 3. How we can do that? Simply this can be written as a with power q minus r, and this is a1 r p minus 1 whole power q minus r, say this is equation number 4. Similarly b, in case of b we needed r minus p is equal to, b is equal to a1 r q minus 1 whole power r minus p, say this equation number 5. And c, in case of c we needed p minus q, and c is equal to a1 r raised to power r minus 1 whole power p minus q. So left hand side multiply with left hand side of all these equations, and right hand side we multiply with the right hand values. So by using equation 4, 5, 6 we can write as a q minus r into b r minus p into c p minus q. This is equal to the values of a is equal to this one, q minus r multiply with the both powers, with a1 power raised to power 1 and r raised to power p minus. So this is a1 q minus r, and this is r, this is pq, and this is minus pr, and this is minus q, and this is minus minus plus r, into values of b, which is a1 power r minus p, and this is r raised to power, this is qr, this is minus qp, this is minus r, and this is plus p, into the values of c, which is a1 raised to power p minus q, and this is r raised to power, this is rp, this is minus rq, this is minus p, and this is minus plus q. So in this case bases are same, power must be added. This is a raised to power q minus r plus r minus p plus p and minus q, into r there is pq and minus pr and minus q plus r plus qr minus qp minus r plus p. So there is plus rp minus rq minus p and plus q. So positive q, negative q, minus r plus r minus p plus, it means that this is a raised to power. Similarly this is plus pq, and there is minus qp minus pr plus rp, all these values are cancelled. So there is r raised to power 0, and this is 1 1, and this is equal to 1. Hence proved that a raised to power q minus r, b raised to power r minus p into c raised to power p minus q, this is equal to 1. The next question number 13. Dear student, in this case geometric series is given, which is infinite geometric series, and condition x is greater than 0, less than 3, because if x is less than 3 then the common ratio must be less than 1 and the sum is possible. So that is why this condition is given. So we have to show that in this case x is equal to 3y1 plus y if the geometric series is given. So simply prove. In this case the first term is x over 3 and the common ratio is second term divided by first term. So this is equal to x by 3, and it must be less than 1 because x is in this case is less than 3, because if we put 2, so 2 by 3 which is less than 1, it means that sum is possible. So in this case the series infinite geometric, so some summation formula is s infinity, this is a1 1 minus r, in this case a1 is given which is x over 3, or r in this case is x over 3. We finding sum for equation number 1. This is equal to x by 3 LCM, this is 3 minus x. So after simplification this is x over 3 minus x because 3 cancel. S infinity, we using equation 1 for sum s infinity. So left hand side in this case this is equal to 1 y, because we finding the sum of equation number 1. So s infinity is y. So simple find the values of x and we get required proof. So this is 3 minus x into y, x, this is equal to 3y minus xy is equal to x. So this is 3y is equal to xy plus x. So this is 3y, x is common in this case, so this is y plus 1, and this is equal to x is equal to 3y divided by 1 plus y, and hence proved. Next question number 14 is the application of geometric series. A ball rebounds to half of the height from which is dropped. If it is dropped from the 10 feet, how far does it travel from the moment it is dropped until the moment of its 8 bounce? In this case, the requirement is that if we drop the ball and after rebounds it covers half distance. For example, if there is a 10 feet, then there is half means there is a 5 feet, and there is 5 by 2, and in this case if we reaches to the 8 bounce, if it is dropped from the 10 feet, how far does it travel? Total, we have to find total distance. It means that we sum of all these distance up to 8 bounds. So in this case it is like a geometric series. The first bounce in this case is 10, and then 10 by 2 half, and then 10 by 2 half plus 10 by 2 half and half plus up to so on. In this case up to the 10th term, up to the 8th term, how much distance he travel? It means that we have to find sum. So simple, dear student, it is a geometric series. This is 10 plus this is 5, and this is 5 by 2, and this is 5 by 4 plus up to so on. It is geometric series. We have to find in this case, find the sum. In this case, this is, say this is question number 1. In this case A1 is 5. In this case common ratio have to how we find common ratio? If we divide second term by its first term, 5 by 2 divided by 5, this is equal to 1 over 2, which is less than 1. So simple formula in case of finite geometric series S, and this is A1, 1 minus r is to power n divided by 1 minus, because r is less than 1. How many terms in this case? There must be 7 terms, because we are not taking 10 in this summation formula. So n in this case is 7. If we take 10, if we taking sum from the first term, then the number of terms are 8. So in this case the number of terms are 7. So simple, putting the values of n, which is 7, A1 which is 5, r which is 1 over 2 whole raised to power 7 divided by r is 1 over 2. So simplify that and get the value, and simple put in equation number 1. So 10 plus this thing, this is the basically answer, and after simplification we have. So simply in this case after simplification you can simplify easily and get the answer, and it is all about exercise 4.5. There is another method of question number 14. Let's take another look of question number 14. There is another method, or it is mostly correct or improved one. For example, in this case 10 plus, and there is 5 over 2, 5 plus 5 by 2, and this must be 5 by 4 plus up to 7th term, because in this case we are not taking 10. 8 term, if 10 is included, in this case 10 is excluded. So simply find the sum and add in this 10. So in this case sum is very simple. A1 in this case is 5 and common ratio in this case r, which is 1 by 2. If we divide this one by this one, this is equal to 2, which is less than 1. So summation formula Sn, n in this case is 7, a1 is in this case is 5. So 1 minus r in this case is 1 by 2 raised to power 7 divided by 1 minus r, which is 1 by 2. So simplify and get the values of sum of 7 terms and plus 10. It is all about exercise 4.5. Dear students, thanks for watching. Inshallah, next time we will start harmonic progressions. Must give your comments, positive comments or suggestions or appreciations. Thank you very much. To be continued. Allah Hafiz.